Hello there, and welcome to Deep Space Sleep. I'm really glad you're here tonight. Beneath every step you take, far below the noise of cities and the rush of daily life, the Earth is resting, holding memories older than oceans, older than mountains, older than anything the human mind can easily imagine. The ground beneath you isn't still. It moves in rhythms too slow to feel, reshapes itself in cycles too long to see, and carries the gentle heartbeat of a planet that has been breathing for more than 4.5 billion years. Every stone you've ever touched began its life in fire, or in ancient seas, or in the quiet pressure of time itself. Every grain of sand was once part of a mountain. Every crystal formed drop by drop, layer by layer. In silence, geology is the story of Earth told in the calmest voice possible, written not in words, but in color, pressure, and age. Tonight, we'll drift together through those stories, through the slow rise of continents, the soft layering of ancient oceans, the quiet glow of minerals forming in the dark, and the deep, steady rhythms that shape the world beneath your feet. Before we begin, let me know in the comments where you're listening from tonight and what the ground is like beneath you there. Is it rock? Is it sand? Is it soil from a distant forest? Your words help other sleepy travelers feel at home on this ancient planet we share. For now, let your breath fall into an easy rhythm. Let your thoughts soften. Let the weight of the day sink gently into the earth. And let's begin. Earth formed from stardust, drifting in a quiet cosmic cloud, a slow gathering of minerals, gas, and ancient fragments left behind by older stars in the darkness of early space. These tiny particles move gently toward one another, guided not by haste, but by the soft pull of gravity. Over millions of years, they merged into larger bodies, each collision warming the growing sphere that would one day become Earth. Nothing about this process was sudden. The planet accumulated layer after layer of material in a gradual, peaceful assembly. That stardust still exists within every rock, every mountain, and every grain of sand. When you touch the ground today, you are touching particles that once floated freely between stars, illuminated only by distant light. Earth began in silence, in drifting clouds older than imagination, forming from the calm, patient motion of the universe itself. Its origins are a reminder that even worlds begin gently. The first minerals of Earth cooled like a slow exhale, solidifying from molten droplets into the earliest crystals the planet ever produced. These minerals formed in a world without oceans, without continents, without life, where heat radiated outward in waves that faded gradually over time. As the surface cooled just enough, tiny crystals began to arrange themselves into orderly patterns, growing atom by atom through a process as calm as dew forming on a quiet morning. These first solid structures became the foundation of all later rocks, the seeds from which mountains, continents, and entire landscapes would eventually rise. Their cooling was not abrupt or violent. It was a long, steady transition from glowing liquid to firm, ancient stone. When you see a crystal today, its form still carries echoes of that early calm, shaped by the universe's softest movements. The minerals that cooled in those first moments hold within them the earliest memory of Earth becoming solid beneath an ancient sky. The hot core of Earth has maintained a steady rhythm across time, a slow and powerful heartbeat deep beneath the surface. Formed from the densest materials during the planet's early melting, The core has remained warm for billions of years, radiating heat outward in a continuous flow, though hidden far below. It moves with calm stability, stirring molten metal in smooth, circular currents. These motions generate Earth's magnetic field, a quiet shield that has protected life since long before it appeared. The core does not pulse in quick beats. Its rhythm is measured in millennia, in cycles older than any mountain range. Every second, it gives off warmth that rises upward through layers of rock, subtly influencing the planet's geology and atmosphere. Even though we never see it, the core is always there, steady and patient, providing the internal energy that keeps Earth dynamic. Its slow, enduring heartbeat reminds us that even the planet's fiercest forces begin in tranquility. Earth's crust formed from fragile early layers of rock, thin at first, slowly thickening as the planet cooled. In its earlier stages, the surface was a restless ocean of molten material, glowing softly as heat radiated into space. Over time, the outer layer cooled enough to become solid, forming plates that drifted atop deeper, warmer rock. These first layers were delicate, easily broken by rising magma or falling asteroids. Yet they laid the foundation for continents and oceans. As more material cooled, the crust grew stronger, creating the stable surface that life would eventually inhabit. This process took millions of years, unfolding in gentle stages rather than sudden leaps. The crust thickened like the skin of a cooling lake, forming slowly, evenly, quietly. Even now, it continues to shift at a pace too slow to feel. The ground beneath you, no matter where you stand, began as one of these early fragile layers, shaped by time and softened by Earth's long cooling breath. The first oceans rose from vapor that condensed into ancient mist, forming when Earth's surface finally cooled enough for water to settle. Early in the planet's history, intense heat caused water to exist only as steam, swirling through the atmosphere in thick, warm clouds. As temperatures dropped, this vapor began to condense, falling as rain that lasted for thousands of years. Drop by drop, these rains gathered into basins, becoming the first oceans calm, dark, and filled with minerals carried from newborn rocks. The process was gentle, a transformation driven by cooling air and soft precipitation. These early waters shaped the surface, smoothing rocks, carving new paths, and creating the environment needed for life's earliest beginnings. When you hear the sound of rain today, you're hearing a faint echo of that ancient condensation, a reminder of the quiet cycles that built Earth's earliest landscapes. The first oceans formed not in chaos, but in slow, continuous breaths of a cooling world. The young continents drifted lightly across Earth's surface, moving as quietly as floating icebergs on a tranquil sea. In the planet's early days, the crust had separated into large plates that glided over deeper layers of warm, softened rock. Their motion was slow enough to be invisible across a lifetime, yet steady enough to reshape oceans and mountains over millions of years. These continents were lighter than the surrounding material, allowing them to ride on the mantle like islands drifting through a warm mist. Even as they collided and separated, the movement remained patient, driven by deep currents far below. Today, we can trace their journey through ancient shorelines and matching rock patterns separated by entire oceans. The continents we stand on were once gathered together in different shapes, drifting through time in a calm, unhurried dance. Their gentle motion reminds us that the planet is always changing, even when everything seems still beneath our feet. Silicates and metals fused together under immense pressure that acted not violently, but steadily, shaping the deep interior of Earth with quiet determination. When the planet was young, temperatures were high enough to melt nearly everything, allowing minerals to separate according to their density. Heavy metal droplets sank inward, while lighter silicates rose toward the surface, forming distinct layers that remain today. This merging happened slowly, guided by gravity and the natural tendency of elements to organize themselves. Despite the enormous forces at work, the process unfolded in smooth transitions rather than abrupt shifts. Over time, crystals grew, melted, and reformed into new patterns, creating the complex mineral structure that fills Earth's crust and mantle. Every gemstone, every grain of sand, and every metal vein began in this early union of elements deep underground. Though we often imagine the planet's interior as chaotic, its formation was shaped by steady pressure and patient heat, sculpting Earth from the inside outward. Earth has been slowing its rotation over billions of years, as if the planet itself has been letting out a long, gradual sigh. When it first formed, a day on Earth lasted only a few hours, with the young planet spinning rapidly from its birth. Over time, the gravitational pull of the Moon gently tugged against this rotation, transferring a small amount of energy outward and lengthening the day. This process continues even now, though at a rate far too small for us to feel. Each century, Earth's rotation slows by just a fraction of a second, creating a subtle shift that accumulates across deep time. The slowing isn't abrupt or disruptive. It's a calm, easing, a soft adjustment, guided by the steady influence of the Moon. By studying ancient corals and sediments, scientists have discovered records of shorter days preserved in natural growth patterns. Earth's gradual deceleration reminds us that even celestial bodies experience change at the quietest possible pace. The oldest minerals on Earth carry within them the faint glow of the planet's earliest moments, preserving traces of sunlight and cosmic energy from a time long before life existed. These tiny crystals formed more than 4 billion years ago, when Earth was still young and covered in oceans of magma. As they solidified, they captured chemical signatures that reveal what the early atmosphere and temperature were like. Some even contain microscopic inclusions believed to record the conditions of Earth's primordial environment. Holding one of these ancient minerals is like holding a memory from the beginning of the world, a silent witness that has survived countless cycles of heat, pressure, erosion, and renewal. Their survival is remarkable, considering the constant reshaping of Earth's surface. Yet these minerals endure, offering a window into a distant era when the planet was still finding its form. In their structure lies a quiet story of origins, written in atomic patterns older than any mountain range. Every stone you encounter is a fragment of Earth's earliest memory, shaped and reshaped across unimaginable spans of time. Rocks form through cycles of heat, pressure, erosion, and renewal, carrying with them subtle records of each stage. A pebble found on a beach may have once been part of a mountain peak, a volcanic flow, or the seafloor of an ancient ocean. Over millions of years, wind, water, and shifting plates broke these stones apart and rebuilt them into new forms. Yet they never lose their deeper history. The minerals inside each rock hold clues about the temperature, pressure, and environment in which they formed. Even the smallest grain of sand contains echoes of worlds that no longer exist. When you pick up a stone, you are holding a piece of Earth's autobiography, written slowly through natural processes that unfold far beyond a human lifespan. Each rock is a quiet archive of the past, carrying the memory of a planet in constant evolution. Metamorphic rocks form under deep pressure that feels almost like a heavy, comforting blanket, embracing every crystal within them. Far below the surface, heat and stress don't shatter the stone, but transform it slowly, guiding minerals to rearrange into new patterns, layer, stretch, twist, and fold over millions of years. Yet, the process remains gentle on a planetary scale. What begins as a simple rock can become marble, schist, or gneiss, each with distinct textures shaped by time's quiet influence. These transformations happen so slowly that even mountains cannot feel their progress. Every stripe, ripple, and shimmer in metamorphic stone is the result of long, patient change. To hold such a rock is to hold evidence of Earth's deep calm, where pressure does not destroy, but reshapes. It is a reminder that strength can come from slow transformation, and that even under immense weight, nature often chooses the softest possible path forward. Molten lava moves through the darkness, like glowing honey, thick and radiant, flowing with a pace that feels deliberate rather than violent. Though intensely hot, its movement is mesmerizingly smooth, advancing in slow waves that illuminate the night with their warm red light. As lava cools, it begins to form delicate crusts that wrinkle and fold, revealing textures shaped by gentle motion. The molten rock beneath continues its steady push, lifting and stretching the surface as if breathing beneath a blanket of heat. Each flow marks a moment in Earth's quiet creation, laying down new land with patient force. Standing near a lava field, you can sense the planet's inner warmth rising toward the surface. Not with aggression, but with ancient purpose. Lava carries minerals that will someday solidify into new stones, new mountains, and new memories of geological time. Its glow is a reminder that Earth is alive beneath us, moving slowly through cycles that never rush. Granite cools at a pace that mirrors the sleep of millions of years, forming slowly in vast chambers deep beneath the surface. Unlike volcanic rocks that solidify quickly, granite takes its time, allowing crystals of quartz, feldspar, and mica to grow slowly and peacefully. Each crystal has room to expand, settling into patterns that appear speckled and serene when the stone is revealed at the surface. This slow cooling process can last longer than entire mountain ranges remain standing. Only after erosion wears away, layers of rock above, does granite finally emerge into the daylight. When you touch a granite boulder, you are feeling minerals that formed in darkness, in stillness, in the ancient quiet of Earth's crust. The stone's strength comes from patience, not force. It is a monument to slowness, showing how time alone can create beauty. Granite's calm endurance reminds us that some of nature's finest work happens far below, in rhythms too gentle to perceive. Sedimentary layers build themselves as quietly as pages stacking in a book, each formed from grains carried by water, wind, or ice over centuries. These tiny particles settle gently on top of one another, creating soft blankets of sand, mud, or organic material. Over thousands of years, these blankets compress into stone, preserving stories of ancient environments. You can trace long-lost riverbeds, oceans, deserts, and forests simply by reading the layers. Some contain ripples left by waves. Others hold fossils of creatures that once moved through shallow seas or quiet lagoons. The calm accumulation continues through ages, forming cliffs, canyons, and mesas that seem frozen in time. These sediments are Earth's diary, written in fine grains rather than ink. To look at a layered rock is to witness millions of years arranged in perfect order. Each stratum a gentle reminder that even the slowest processes can build landscapes of extraordinary beauty and depth. Crystals form when mineral-rich water slowly withdraws, leaving behind tiny structures that grow with remarkable grace. In caves, this water drips patiently from ceilings and gathers on the ground, depositing small amounts of dissolved minerals with each droplet. Over years, these minerals link together in repeating patterns, creating clear, symmetrical shapes that seem almost impossibly delicate. Some crystals grow so slowly that a single inch can take hundreds of years to form. Their clarity reflects the calm environment in which they grow, shielded from wind, noise, and sudden change. Whether it is quartz forming deep underground or calcite growing in a silent cavern, each crystal is a quiet sculpture shaped by time and water. When light passes through them, they reveal intricate inner structures, like frozen moments of geological memory. Crystals remind us that beauty often forms in silence, emerging not from force, but from patient, steady growth in hidden places beneath the earth. Limestone is the fossil memory of ancient seas, formed from the quiet accumulation of shells, corals, and microscopic organisms that once drifted through warm, shallow waters. Over millions of years, their delicate skeletons settled onto the seafloor in soft layers, gradually building up into thick beds of calcium-rich sediment. As pressure increased, these layers compressed into stone, preserving tiny details of a world that no longer exists. Fossils within limestone record the shape of ancient reefs, the rhythm of old tides, and the life of creatures too small to see without magnification. When we walk on limestone, we are stepping on the remains of oceans that have been gone for hundreds of millions of years. Each piece of the rock carries a faint whisper of waves, a memory of sunlight filtering through blue water, and the gentle drifting of marine life. Limestone is a quiet archive of Earth's past, holding entire ecosystems in its soft, barley layers. Tectonic plates move more slowly than fingernails grow, shifting at only centimeters per year. Yet their patient movement shapes continents, oceans, and mountains. These vast slabs of Earth's crust float on the semi-fluid mantle beneath them, carried by currents so gradual they cannot be detected without precise instruments. Despite this slowness, their motion is powerful over geological time, guiding the rise of mountain ranges and the opening of ocean basins. When plates collide, they do so with the steady force of deep earth processes, folding rock upward into peaks that will stand for millions of years. When plates pull apart, they create new crust through gentle upwelling of molten rock. The world we see today is the result of countless quiet shifts, each imperceptible in the moment, but monumental across ages. The calm motion of tectonic plates is a reminder that transformation does not need speed. Even the slowest drift can reshape the entire surface of a planet. Mountain ranges rise like the long, slow breath of the earth, lifting upward over millions of years as tectonic plates push against one another. Though we imagine mountains forming through violent events, their growth is far more gradual, unfolding so slowly that no human lifetime is long enough to witness even a small fraction of it. Deep beneath the surface, rock is compressed, folded, and stacked, creating layers that bend like soft fabric over enormous timescales. As uplift continues, erosion gently carves the peaks, shaping follies, ridges, and slopes that trace the hidden motions below. Standing in a mountain valley, you are surrounded by stone that has been rising inch by inch for eons, guided by steady forces that never rush. The air, the cliffs, and the long shadows all carry the sense of Earth breathing upward. Mountains are Earth's quiet exhalations, built from the slow work of time and pressure, reminders of the planet's steady, enduring strength. Canyons form through erosion that feels more like patient carving than destruction, shaped by water flowing gently across rock for thousands upon thousands of years. A river does not rush to create a canyon. Instead, it glides along the same path day after day, carrying grains of sediment that slowly wear away the stone beneath it. Over time, the river deepens its channel, revealing layers of rock that record ancient climates, vanished lakes, and long-buried landscapes. Wind, rain, and seasonal floods add their subtle touches, smoothing edges and creating curves in the canyon walls. The process is so gradual that the canyon appears frozen in time. Though it is always changing, even the smallest streams can create deep gorges if given enough time. When you look down into a canyon, you are seeing the artistry of water measured not in years, but in millennia. Its shape is a testament to the gentle persistence of natural forces moving at the slowest possible pace. Volcanic ash nourishes soil through its quiet life cycle, beginning as tiny particles launched high into the sky during an eruption. Though the eruption itself is dramatic, the ash settles softly afterward, drifting down like fine powder over the landscape. These particles are rich in minerals such as potassium, calcium, and phosphorus, which slowly dissolve into the ground as rain and groundwater move through the soil. Over years and centuries, volcanic ash breaks down into fertile earth that supports forests, grasslands, and crops. Many of the world's most productive farmlands, from Indonesia to Central America, owe their richness to ancient layers of ash. Plants thrive in this soil, drawing nutrients that once existed deep within the Earth's crust. Volcanic ash completes a gentle cycle, born in fire, carried on the wind, settled in silence, and eventually becoming the foundation for new life. It reminds us that even dramatic events can leave behind a legacy of quiet renewal. Fossils gently preserve the shapes of lives that vanished long before humans existed, capturing details that would otherwise have faded into the deep past. When a creature dies, its soft tissue disappears, but its bones, shells, or impressions may settle into quiet sediment on the seafloor or along ancient riverbanks. Over thousands of years, these sediments harden into stone, locking the shapes in place. Minerals seep into the remains, creating replicas that can last hundreds of millions of years. When we find a fossil, we are not just looking at bone or shell. We are seeing a moment frozen at the intersection of life and geology, a quiet pause in time that endured through heat, pressure, and shifting continents. Fossils remind us that time is not lost, but held gently in stone, waiting patiently to be rediscovered. Each fossil carries the whisper of an ancient world, a delicate echo of creatures that once breathed beneath entirely different skies. Amber carries within it the trapped breath of ancient forests, preserving tiny worlds sealed away for tens of millions of years. When tree resin dripped slowly down bark in long-vanished woodlands, it sometimes captured insects. In pollen, droplets of air, and fragments of leaves. Over time, this resin hardened underground, transforming into amber while keeping its fragile contents untouched. Looking into a piece of amber is like looking through a golden window into deep time. The insects inside still hold their delicate wings, their antennae, even the faint outline of their eyes. The air bubbles contain atmosphere from ages long before humanity existed. Amber holds not just objects, but entire moments. Suspended in glowing stillness, it preserves the feeling of ancient forests where sunlight filtered gently through tall canopies and soft winds carried the scent of pine. To hold amber is to hold a memory so gentle and so well kept that time seems to stop for a moment. Zircon crystals carry within them the oldest time on Earth, some dating back 4 billion years, almost to the planet's beginning. These tiny minerals formed when Earth's surface was still cooling, when oceans were only just beginning to appear. Zircons are incredibly resilient, surviving heat, pressure, erosion, and recycling through multiple generations of rock. Inside them, trapped atoms reveal what the young Earth was like. Its temperature, its water, its early atmosphere. Scientists study zircons to understand the world before continents existed, before life arose, before even the oldest rocks formed. Each crystal is smaller than a grain of sand, yet it holds more history than entire mountain ranges. Zircons are like time capsules carried through deep cycles of geology, quietly preserving a record of Earth's earliest moments. Holding one is like holding a fragment of the planet's first memory, a reminder of how far Earth has traveled and how gently time can be kept within a single shimmering mineral. Thin laminations in rock preserve the rhythm of ancient seasons, recording wet and dry periods with delicate precision. These microscopic layers form when sediments settle slowly in calm lakes or quiet tidal flats, each season leaving behind a slightly different pattern of grains. A rainy season might leave fine mud, while a dry season deposits coarser silt or sand. Over thousands of years, these annual layers stack into stone, creating a geological diary written in alternating bands. Scientists can count these layers much like the rings of a tree, reconstructing climate cycles, rainfall patterns, and environmental changes that occurred long before written history. Each layer is incredibly thin, sometimes no thicker than a strand of hair, yet together they represent vast stretches of time. To study them is to witness a slow, steady heartbeat of ancient landscapes. These gentle laminations remind us that time often reveals itself not through sudden events, but through quiet, repeated rhythms of nature. Sandstone carries the memory of wind-shaped deserts, holding within its grains the traces of dunes that once moved across wide, open plains. Each grain began as a fragment broken from older rocks, carried by wind or water and polished over enormous spans of time. As these grains piled into dunes, the wind carved them into smooth, sweeping shapes that advanced slowly across the landscape. When water or pressure later cemented these dunes into stone, The original patterns remained preserved. You can still see them today as gentle, cross-bedded lines, tilted at angles that reveal the direction the ancient winds once blew. These patterns capture the quiet movement of sand under a sun that rose and set over countless empty horizons. Sandstone is more than rock. It is a memory of long-forgotten deserts, of shifting dunes, of silent nights under vast, star-bright skies. Each layer holds the calm persistence of wind shaping the land. One grain at a time, shale records the slow accumulation of sedimentary pressure, capturing the weight of countless seasons settling gently over one another. It forms in calm waters where fine particles like clay and silt drift downward through stillness, coming to rest in quiet layers over thousands of years. These layers compact into thin sheets that crack softly along natural plains. When you hold a piece of shale, you are holding the memory of mud that once settled on the floor of an ancient lake or sea, compressed so gradually that each layer still reflects the rhythm of long-vanished environments. Fossils of delicate organisms often hide within shale's thin pages, preserved not by violence, but by stillness. The rock splits easily because it was formed through gentle pressure rather than sudden force. Its structure is like a geologic notebook, each layer a line written by time. Shale reminds us that the world is shaped not only by eruptions and upheaval, but also by quiet, steady accumulation. Volcanic rocks carry the whispered stories of ancient magma, solidified traces of Earth's deep interior rising briefly to the surface. When molten rock travels upward through cracks, it cools into forms that range from glassy obsidian to porous pumice, each texture reflecting the path it took. Although volcanic eruptions can be dramatic, the magma itself moves with a hidden softness beneath the crust, flowing through chambers like slow, glowing rivers. Once cooled, volcanic rocks preserve chemical signatures that reveal temperatures, mineral compositions, and the conditions deep within the mantle. Holding a volcanic stone is like holding a cooled ember from Earth's interior, a small piece of heat transformed into quiet solidity. Even the roughest lava rock carries within it the silent memory of a time when it glowed, moved, and breathed in the darkness of underground spaces. These stones are Earth's deep murmurs, frozen into form, yet still carrying the ancient warmth of the planet's core. Mica reflects light with the softness of a still lake, its shimmering layers formed through slow mineral growth deep within the crust. Thin sheets of mica peel apart easily, each layer smooth, delicate, and almost weightless. These sheets grew as atoms aligned themselves into perfect patterns under gentle heat and pressure, creating a mineral that captures and scatters light in calming, silvery flashes. When sunlight hits a piece of mica, the reflections shift gently like ripples across water, reminding you of quiet mornings by a calm shore. Its resilience allows it to survive weathering, erosion, and metamorphism. Appearing in rocks from ancient mountains to younger sediments, mica's subtle sparkle has guided travelers, inspired storytellers, and brought a soft touch of light to landscapes for countless ages. To hold mica is to hold a fragment of Earth's elegance, a mineral that mirrors the reflective stillness of nature. Its tiny, glittering surfaces carry the quiet beauty of geological time. Ophiolites reveal the hidden floors of ancient oceans, lifted slowly onto land through patient tectonic motion. These rare formations consist of deep-sea crust and upper mantle rocks that were once far beneath the waves, created in spreading centers where new ocean floor formed over millions of years. Shifting plates pushed these underwater layers upward until they emerged on land, offering geologists a direct glimpse into Earth's interior structure. Walking on an ophiolite is like walking on the memory of an ocean that vanished long ago. Its basalt, gabbro, and serpentine layers still arranged in the order they held beneath the sea. The minerals within them preserve clues about ancient hydrothermal vents, ocean chemistry, and the temperature of early Earth. These rocks traveled an extraordinary journey from ocean depths to mountain peaks, carried not by sudden violence, but by slow, determined movement. Ophiolites remind us that Earth constantly reshapes itself, lifting the quietest places into the light. Every stone you pass on the road is a miniature library, holding chapters of Earth's history written in minerals, textures, and patterns. Even the smallest pebble has lived through cycles of heat, pressure, erosion, and transformation. It may have once been part of a towering mountain or a seafloor buried under miles of water. Over time, natural forces shaped it into its current form, carving away rough edges and revealing new surfaces like pages turned by the wind. If you look closely, you may see grains that record ancient rivers, crystals that grew in deep chambers, or colors that speak of long-lost environments. Each stone contains knowledge older than humanity and older than many continents. They do not boast their age or reveal their stories loudly. Instead, they offer quiet hints to anyone who pauses long enough to notice their subtle features. Stones are patient storytellers, carrying the gentle weight of deep time wherever they rest. Earth's molten outer core generates the magnetic field that quietly shields our planet, creating a protective embrace around everything living above it. Though the metal within this layer is incredibly hot and constantly in motion, its flow is steady and rhythmic, almost like the pulse of a hidden heartbeat. As liquid iron swirls, it creates electric currents that rise and wrap themselves around the planet, forming a magnetic cocoon that deflects harmful solar particles. This field is invisible, yet every compass needle on Earth responds to its gentle pull. It has existed for billions of years, guiding migrating animals, protecting the atmosphere, and shaping the auroras that glow softly at the poles. Deep beneath our feet, the outer core churns with a calm determination, never resting, never rushing. It is one of Earth's most profound gifts, a silent, enduring shield created not by force, but by the graceful motion of molten metal in the dark. Convection currents in the mantle behave like an immense, slow-moving ocean of stone, flowing so gradually that entire continents drift upon it without us ever sensing the motion. This rock is solid, yet over millions of years it moves with the softness of warm wax, rising where it is hot and sinking where it cools. These vast circulations carry heat from Earth's interior toward the surface, shaping the movement of tectonic plates and gently sculpting the planet's outer shell. Even though the mantle spans thousands of kilometers in thickness, its flow is steady and harmonious, following patterns that persist for tens of millions of years. If you could watch its motion in fast forward, it would look like a deep, glowing sea, swirling and shifting with a quiet grace. Every mountain, ocean basin, and volcanic arc owes its existence to this slow, rhythmic movement beneath us. The mantle is Earth's hidden ocean, guiding the planet's evolution with calm, persistent energy. Geothermal heat spreads outward from Earth's interior like the warm breath of an ancient hearth, rising through layers of stone in gentle waves. This heat originates from the planet's formation and from the slow decay of radioactive elements deep underground. Though intensely hot at its source, the warmth that reaches the crust feels subtle and patient, influencing rock, water, and even life in delicate ways. It fuels geysers, hot springs, and deep hydrothermal systems that have nurtured microorganisms for billions of years. In some regions, geothermal heat softens the crust, creating zones where magma can rise more easily. In others, it warms groundwater, creating quiet reservoirs of thermal energy. This steady release of warmth prevents Earth's interior from cooling too quickly, allowing the planet to remain geologically active, like the fading heat of a long-burning fire. Geothermal energy flows continuously, offering a reminder that the planet carries within it a deep, enduring warmth older than any mountain range or sea. Deep earthquakes send waves through the planet like distant echoes traveling through a vast, irresonant body. These quakes occur far below the crust, in zones where rocks are pressed under enormous pressure and temperature. Instead of fracturing violently like shallow earthquakes, deep quakes often release energy in smoother, more continuous motions. Their waves travel great distances, passing through mantle layers and reflecting changes in density and composition. Scientists use these waves to map Earth's interior, listening to the planet the way one might listen to the echoes inside a hollow instrument. When the waves reach the surface, they are usually gentle enough that no one feels them, yet they carry invaluable information about the deep Earth. These distant vibrations remind us that the planet is alive with internal motion. Even in the quietest moments, deep earthquakes are like Earth's soft whispers, subtle signals from layers we can never touch but can sense through careful observation. Magma's heat keeps the planet alive from within, supplying the energy that fuels volcanoes, drive plate movement, and shapes the world above. This molten rock forms in pockets where the mantle melts, rising slowly through the crust with a persistence that spans thousands of years. Though magma is intensely hot, its journey upward is steady and unhurried, guided by buoyancy and pressure rather than explosive force. Only when it reaches the surface does it reveal its fiery nature. Deep underground, magma flows in chambers like glowing viscous rivers, storing heat that radiates into surrounding rock. This warmth helps create geothermal systems, influences the formation of minerals, and sustains the dynamic processes that prevent Earth from becoming cold and geologically silent. Magma is the quiet engine of the planet, a reservoir of ancient heat that moves with patience and purpose. Its presence reminds us that beneath the solid ground we walk on lies a world of slow, powerful, and enduring energy. Hot plumes rise through the mantle like bubbles drifting upward in warm water, carrying deep heat toward the surface in slow, graceful motions. These plumes begin far below, in regions where temperatures are high enough to soften solid rock into a viscous, flowing state. As they rise, they expand gently, creating towering columns of warm mantle material that can persist for tens of millions of years. When a plume reaches the base of the crust, it may cause gentle uplift or give birth to volcanic activity, but the motion itself is patient and unhurried. If you could watch Earth in accelerated time, these plumes would look like luminous fountains rising through a dark ocean, glowing with ancient heat. They remind us that even deep inside the planet, movement can be calm and rhythmic, shaping the world above, not through sudden force, but through the quiet, upward drift of warmth that has traveled thousands of kilometers through stone. Subduction draws old oceanic crust back into the mantle, gently recycling ancient rock into the planet's ongoing geological cycle. Although the process involves immense forces, the motion itself is astonishingly slow, only a few centimeters per year, as one plate slides beneath another like a page turning in a book of stone. As the crust descends, it heats gradually, releasing water and minerals that help melt surrounding material, contributing to future magma and new crust formation. This cycle is Earth's way of renewing itself, transforming old seafloors into fresh volcanic arcs and mountain ranges over millions of years. The rocks that once lay beneath deep oceans eventually reappear in new forms, rising in distant continents or emerging as new islands. Subduction shows that nothing in geology is wasted. Every layer of crust returns to the deep earth to begin again. It is a reminder of the planet's quiet resilience, where even destruction is simply another chapter in an ongoing, gentle cycle of renewal. Rifts open at a pace as slow and delicate as cracks forming in thin ice, stretching Earth's crust at rates almost impossible to detect without instruments. These rifts begin where tectonic forces pull plates apart, creating long valleys that widen over millions of years. Magma may rise quietly from below, filling the gap with new rock, or simply warming the crust enough to make it more flexible. The landscapes formed by rifting are vast yet peaceful, with broad plains, gentle ridges, and long fissures that look like careful etchings across the surface. In time, a rift may grow into a new ocean basin, though the transformation takes so long that entire civilizations could rise and vanish before noticeable change occurs. Rifts are the planet's soft stretches, regions where Earth exhales and relaxes its surface. They show that even the creation of oceans, continents, and mountains begins with movement so slow and quiet that the ground seems motionless to the human eye. Volcanic islands rise from the ocean like musical notes appearing in a long stone symphony, created by magma that reaches the surface in gentle, persiste pulse. Far below, mantle plumes or spreading centers supply molten rock that builds upward layer by layer until it finally breaks through the seabed. The first eruptions happen in total darkness, hidden beneath immense pressure, but over time, the growing mountain approaches the surface, creating shallow reefs, then black sand beaches, and eventually lush, volcanic islands. Even though eruptions can be dramatic, the growth of the island itself is steady and patient, shaped by countless flows of lava cooling into solid rock. Many island chains, like Hawaii or the Canaries, are records of these long journeys, with each island marking where the plume once stood. These islands remind us that the Earth composes its landscape slowly, with patterns and rhythms that unfold over millions of years, guided by deep, enduring energy rising from within. The mantle moves with a gentleness that belies its immense power, shifting entire continents through motions that feel more like drifting than force. Though the mantle is solid, its warm, ductile nature allows it to flow over geological time, pushing plates together, pulling them apart, and creating the foundations of mountains, oceans, and volcanic arcs. This movement is so slow that a human lifetime registers none of it. Yet, over hundreds of millions of years, it rearranges the map of the world. Continents glide across the globe, collide to form supercontinents, break apart, and drift again. All of this begins with subtle convection currents deep in the mantle, rising and sinking in calm cycles. The mantle's movement is Earth's quiet engine, shaping landscapes through patient persistence rather than sudden change. It reminds us that even beneath solid ground lies a world in continuous, graceful motion, guiding the evolution of the planet with a strength that works softly but transforms everything. Deserts form through winds that blow for thousands of years, shaping the land not with violence but with patient repetition. Grains of sand drift slowly across dry plains, carried by breezes that rise and fall with the sun. Over time, these movements sculpt dunes that shift like living sculptures, their curves softened by countless sunrises and sunsets. Desert landscapes are shaped by absence as much as presence, where rivers that once flowed leave behind wide basins and ancient lakebeds that echo with silence. The air is clear, the horizon distant, and the sand remembers every gust of wind that touched it. Even the harshest deserts were once fertile places, transformed gradually as climates changed and rainfall faded. To stand in a desert today is to feel the memory of deep time written in sand, shaped by wind that has never hurried. Deserts remind us that landscapes can be created not through force, but through the calm persistence of nature. Glaciers carve valleys with a softness that belies their immense size, moving so slowly that the motion is invisible yet powerful enough to reshape entire mountain ranges. These rivers of ice begin high in cold basins, where snow accumulates year after year, compressing into clear, blue ice. As a glacier flows downhill, its smooth rock surface deepens follies and leaves behind graceful U-shaped basins. When the ice eventually retreats, the marks they create are not jagged wounds but broad, polished forms that feel almost intentional, like gentle strokes from a giant sculptor. When glaciers melt, they leave behind quiet lakes, scattered boulders, and rolling moraines that trace the path of their ancient journey. These landscapes carry the cool memory of ages when ice dominated the world, moving with a rhythm far slower than seasons or lifetimes. Glacial valleys remind us that even thick, heavy ice can shape the earth with patience, carving beauty through steady, silent motion. Volcanoes create fertile basaltic soils that appear dark and rich, formed from lava flows that once glowed with intense heat. As basalt cools, it breaks into fine particles over thousands of years, transforming into soil that nurtures forests, crops, and entire ecosystems. This soil is packed with minerals like iron, magnesium, and calcium, supplying nutrients that support vibrant plant life. Regions built from basalt often become some of the most productive lands on Earth, with lush vegetation rising from stone that began its life deep in the mantle. The transformation from molten rock to fertile soil is a gentle reminder of nature's cycles, where something born in fire becomes the foundation of growth. Volcanoes may erupt suddenly, but the landscapes they leave behind develop in quiet, steady stages, each rainfall helping to soften the rock and feed the earth. Basaltic soil is Earth's way of turning ancient fire into new life, a slow renewal that continues long after eruptions fade. Limestone caves grow stalactites and stalagmites as water drips quietly through stone, creating formations that resemble frozen waterfalls. Each drop carries dissolved minerals that crystallize when the water meets air, leaving behind a tiny ring of calcite. Over centuries, these rings build into long, delicate structures that hang from ceilings or rise from the cave floor. The process is incredibly slow, with some formations growing only a millimeter per decade, yet the resulting shapes appear fluid and graceful, as if carved by flowing water in a single motion. Inside these caves, sound is muted, air is cool, and time feels suspended. Shadows move gently across the formations, highlighting their smooth curves and translucent edges. Walking through a limestone cave is like entering a natural cathedral sculpted by patience alone. Every stalactite is a testament to quiet persistence. Formed by the softest movement of water through ancient stone, underground rivers carve stone arches and domes in silence, moving through hidden chambers beneath the surface with soft persistence. These waters travel through cracks and pores in the rock, gradually widening them into tunnels and passageways. Over thousands of years, the flowing water smooths ceilings into graceful curves and polishes walls into shimmering surfaces. In some places, the river dissolves limestone, creating vast caverns where echoes drift softly through the darkness. The shapes formed by these unseen currents feel gentle, almost musical, as if the earth itself has been sculpted by flowing melody. When the river eventually changes course or dries up, it leaves behind empty rooms filled with silent beauty. These underground landscapes remind us that some of Earth's most enchanting forms are created far from sunlight, shaped by patient water that works quietly beneath our feet. The arches, domes, and tunnels they leave behind are the hidden poetry of geological time. Sand dunes change shape every night, shifting under the quiet guidance of the wind. Each grain of sand moves only a tiny distance at a time, lifted gently by breezes that rise after sunset and settle again before dawn. These movements accumulate into sweeping curves and soft ridges that appear new each morning. Even though they form through patient repetition, moonlight glides across their surfaces, revealing delicate ripples left by the previous night's wind. In the silence of the desert, dunes seem alive, breathing in slow motion, drifting as though following an ancient rhythm. Over years, entire fields of dunes migrate across valleys, swallowing old landscapes and revealing new ones. There is no sound, no rush, only the soft whisper of wind sculpting sand into shapes that feel almost fluid. Dunes remind us that even landscapes made of countless tiny grains can transform with incredible grace and stillness. Guided only by the gentlest touch of nature, ancient mountain ranges wear down into rounded hills over millions of years, their jagged peaks softened by rain, frost, and wind. As erosion takes place grain by grain, the mountains lose their sharp edges, becoming gentle slopes and rolling ridgelines that blend seamlessly into the horizon. These old hills are the remains of once towering giants, shaped not by sudden collapse, but by slow, persistent weathering. Water seeps into cracks and widens them through repeated freezing and thawing, while plant roots pry apart rock and carry minerals back into the soil. The transformation is so gradual that no single moment stands out, yet the change is profound across time. Walking through such a landscape feels like stepping into the memory of mountains long gone, their grandeur softened into calm forms. These rounded hills are geological lullabies, reminders that even the tallest peaks eventually settle into peaceful shapes carved by patience and time. Honeycomb weathering forms through the delicate action of salty sea spray seeping into rock, creating patterns that resemble intricate stone lace. When ocean mist lands on rocky surfaces, tiny droplets carry dissolved salts deep into pores and cracks. As the water evaporates under sun and wind, the salt crystals expand gently, pushing the rock outward from within. This slow process removes weaker grains and leaves behind networks of small cavities, each shaped by years of subtle interaction between moisture, minerals, and air. The resulting texture feels almost organic. With pockets arranged like cells in a natural mosaic, these formations often appear on coastal cliffs or boulders exposed to maritime winds, testifying to the quiet, sculpting power of the sea. Honeycomb weathering shows how even the softest forces can create intricate beauty, working grain by grain in peaceful patience. It is the ocean's whisper carved into stone, a subtle signature of salt, air, and time. Marine terraces tell the story of ancient sea levels, preserved as flat steps along coasts that were once shorelines. These terraces form when waves carve a platform into rock, then retreat as land rises or sea levels fall. Over thousands of years, a series of terraces may develop, each one marking a former coastline. Standing on one of these broad, level surfaces feels like standing on the memory of waves that once touched that very place, carrying the rhythm of tides long past. Fossils, shells, and rounded stones often remain scattered across these terraces, quiet evidence of beaches that disappeared ages ago. Scientists read these terraces like chapters in a book, tracing shifts in climate, tectonic uplift, and glacial cycles. Though shaped by powerful forces, marine terraces themselves feel calm and expansive, offering wide views and a sense of geological time stretching far beyond human history. They are peaceful reminders that oceans rise and fall in slow, steady rhythms. Granite along the coastline becomes polished and sculpted by waves, transformed over centuries into natural artworks shaped by water. With each tide, small grains of sand and fragments of shells swirl around the rock, wearing it down in smooth, rhythmic motions. The granite slowly loses its sharp edges, developing soft curves and rounded hollows that reflect the flow of the sea. At sunrise, these shapes glow under golden light, revealing patterns within the granite's crystals that shimmer like tiny stars. The interaction between stone and water is patient and harmonious, with waves never forcing but gently guiding the sculpture. Over lifetimes, boulders become smooth platforms. Tide pools form where the ocean has carved small basins, and cliffs retreat by only a few millimeters each year. Granite coastlines show the quiet artistry of the ocean, a collaboration between rock and water that creates beauty through continuous, tender touch. The result is a landscape that feels both ancient and infinitely soft. Quartz grows slowly drop by drop from warm, mineral-rich solutions, forming crystals that seem to rise out of stillness itself. Deep underground, water heated by Earth's internal warmth dissolves tiny amounts of silica from surrounding rocks. When the solution cools or evaporates, the silica begins to crystallize, attaching itself molecule by molecule onto the growing quartz. The process is incredibly patient, often taking thousands or millions of years. Yet each tiny addition builds a crystal with perfect geometric clarity. Quartz captures light in gentle ways, scattering it through its interior planes like faint glimmers of sunrise. When you hold a piece of quartz, you are touching the memory of water that once dripped through dark, hidden spaces, depositing tiny gifts of mineral with every drop. Quartz grows only as fast as the earth allows, never rushing, never forcing its form. Its clarity is a tribute to calmness, shaped by the slow, steady chemistry of deep time. Calcite forms prismatic shapes when water drips softly in darkness, creating crystals that seem to glow from within. Inside caves, tiny droplets saturated with dissolved calcium carbonate fall from ceilings and splash onto the ground. As each drop loses carbon dioxide to the still cave air, a minute layer of calcite is left behind. Over centuries, these layers build into transparent prisms and intricate crystal clusters that resemble frozen light. Calcite bends and splits light passing through it, giving the mineral a quiet magic that feels almost otherworldly. The shapes it forms depend entirely on the conditions around it: temperature, humidity, and the slow rhythm of dripping water. Calcite crystals are delicate records of countless gentle drops, each adding its own thread to a larger tapestry of stone. In the silence of a cave, calcite feels like the earth is painting with minerals, crafting sculptures out of patience and time. Its beauty comes from stillness, from repetition, and from the quiet chemistry of underground worlds. Amethyst develops its soft purple color from trace amounts of iron resting quietly within the crystal structure, coloring the quartz as it forms. When silica-rich fluids cool slowly in cavities beneath ancient lava flows, quartz crystals begin to grow, incorporating small atoms of iron that later respond to natural radiation in the surrounding rock. Over millions of years, this interaction turns the crystal's various shades of violet, from pale lavender to deep sunset purple. The process is so gentle and gradual that no moment marks the crystal's change. Instead, the color blooms inside the mineral like a sleeping pigment awakening. Amethyst geodes often form in hollow spaces, once filled with gas inside cooling lava, creating stunning chambers lined with sparkling crystals. Holding an amethyst is like holding a small twilight sky, its color carrying the quiet history of volcanic landscapes and slow chemical transformation. The stone's serene hue is a reminder that beauty often comes from the most patient processes of the earth. Opal contains a compressed rainbow within it, formed from countless microscopic spheres of silica arranged in an orderly pattern. These tiny spheres scatter light, separating it into vivid flashes of green, red, blue, and gold that shimmer as the stone moves. Opal begins as water carrying dissolved silica seeps into cracks and cavities in rock. Over long periods, the water evaporates, leaving behind a gel-like material that gradually hardens into opal. The play of color, known as opalescence, emerges only when the spheres are uniform enough to diffract light smoothly. Each color shimmer is a gentle reminder of the mineral's delicate internal architecture, built grain by grain in silence. Opal's softness and glow make it feel alive, as if it holds a small piece of trapped sunlight or a muted storm of color frozen in time. It is one of the most soothing minerals to observe, its hues shifting like the calm ripple of a rainbow reflected in still water. Beryl carries the soft green of ancient oceans, its color shaped by trace elements that settled into the crystal as it formed in deep, warm cavities of the crust. When beryl grows in granitic environments, elements like chromium or vanadium slip gently into its structure, giving rise to the cool green shades known as emerald. Other varieties, such as aquamarine, develop lighter, clearer colors reminiscent of shallow seas under morning light. The growth of beryl is slow and deliberate, requiring just the right temperature, pressure, and chemistry to align its hexagonal crystals. When polished, beryl reflects light with a calming glow, its surface holding a quiet depth that feels almost aquatic. Each crystal records the chemistry of the rock in which it grew, acting as a soft echo of long-vanished geological conditions. To hold beryl is to touch a fragment of ancient earth, a mineral shaped by the steady, patient flow of minerals through stone over millions of peaceful years. Pyrite shines like sunlight that has been quietly kept inside stone for millions of years, its metallic luster catching light in a way that feels warm, even though the mineral is cool to the touch. Formed in low-oxygen environments deep underground, pyrite grows slowly from iron and sulfur that gather in perfect geometric arrangements. Its golden surfaces reflect light in sharp but comforting flashes, giving it the nickname "Fool's Gold." Though its beauty is unmistakable, when pyrite forms in cubes or clusters, each face looks like it was polished by time itself, mirroring the glow of a sunbeam trapped long ago. In ancient seas, pyrite grew around tiny organisms and left preserves of their shapes that still remain in the rock today. Holding pyrite is like holding a fragment of captured brightness, a piece of earth that learned to shine quietly from within. It is a reminder that even the deepest, darkest places underground can create beauty that glows softly in your hand. Fluorite glows under ultraviolet light as gently as a breath, revealing colors that seem to appear from nowhere. This mineral forms in veins and cavities where warm water rich in dissolved minerals slowly deposits layer after layer of crystal. Under normal light, fluorite may show greens, purples, blues, or clear tones, each band telling a story of shifting chemistry deep beneath the surface. But under ultraviolet light, it awakens with a soft fluorescence, glowing like a quiet lantern. The light it emits is cool and soothing, almost like moonlight held inside a gemstone. Each crystal grew from slow cooling and gentle chemical changes, its shape forming patiently over long stretches of time. Fluorite's glowing response to ultraviolet light feels like a secret it reveals only when invited, a hidden pulse of color that flickers softly in the dark. Observing fluorite is like watching Earth exhale light, a delicate reminder of the quiet magic that minerals can hold within their structure. Moonstone reflects light the way mist reflects dawn, scattering brightness into soft, dreamy glows that shift with every small movement of the stone. This effect, called adulorescence, comes from layers of microscopic feldspar plates stacked within the mineral. As light passes through these layers, it bends and scatters, creating a gentle shimmer that seems to float beneath the surface like a drifting cloud. Moonstone grows slowly in igneous rocks, forming in spaces where minerals have time to settle into orderly layers. Its pale glow has reminded people for centuries of moonlit nights, calm water, and soft early morning fog. To hold moonstone is to hold something that never feels harsh or sharp. It carries a softness that mirrors the quiet places of the natural world. Its shifting light seems to breathe as you move it, offering a soothing, ethereal beauty that invites stillness. Moonstone is the mineral form of a whispered luminance, a calm glow preserved within stone. Jade forms under high pressure deep below mountain belts. Its crystals lock together so tightly that the mineral feels almost like stone being gently embraced. This interlocking structure gives jade both its strength and its smooth, calming texture, making it a symbol of longevity and protection in many cultures. Jade begins as minerals like nephrite or jadeite, that are slowly compressed and heated as tectonic plates push together. Over millions of years, this steady pressure knits the crystals into a tough but serene rock with colors ranging from milky white to deep green. When polished, jade carries a soft, waxy glow that feels inviting to the touch. Its cool surface warms slowly in the hand, as if responding to the presence of the person holding it. Jade's formation is a story of pressure without violence, transformation without fracture. It is stone that has been strengthened by gentle constraint, a quiet testament to the power of time held in calm, firm embrace. Every crystal is the result of time falling as slowly as ancient snow, forming through the quiet accumulation of atoms, arranging themselves in perfect harmony. Whether the crystal grows in a cooling magma chamber, a dissolving vein of minerals, or a droplet of water rich with dissolved elements, its creation depends on stillness and patience. Crystals form when molecules attach themselves one by one to a growing structure, following natural patterns shaped by chemistry and temperature. Some crystals grow in hours, others in centuries, but all share a sense of order born from gentle repetition. When you look into a crystal, you can almost see the layers of time that built it, each addition as soft and imperceptible as a single snowflake settling on a quiet field. Crystals remind us that beauty often forms at a pace too slow for the human eye to notice, emerging only after long periods of quiet growth. They are time-made visible, shaped through an ancient, peaceful rhythm. Ice age cycles arrive and depart like the long breaths of the planet, unfolding over tens of thousands of years, with a rhythm so slow it feels almost timeless. These glacial periods begin when slight changes in Earth's orbit reduce sunlight in high latitudes, allowing snow to linger from year to year. Over centuries, the snow builds into vast sheets of ice that creep across continents, reshaping valleys and redirecting rivers. When conditions shift again, the ice melts back with equal patience, revealing new landscapes smoothed and polished by its passage. These cycles have repeated many times, each one leaving quiet signatures in sediments, fossils, and ancient shorelines. To imagine an ice age is to imagine a world where cold moves like a slow tide, advancing and retreating in harmony with Earth's orbital rhythms. The planet breathes through these cycles, exhaling warmth and inhaling cold, holding the memory of deep time in the motion of ice across its surface. Sea levels rise and fall on million-year cycles, responding to changes in climate, ice volume, and the shape of ocean basins. When ice sheets grow, they lock away enormous amounts of water, lowering sea levels and exposing continental shelves that were once underwater. When the climate warms, the ice melts and the oceans swell, flooding lowlands and creating new coastlines. These movements are so gradual that entire ecosystems adapt and vanish without a single dramatic moment marking the change. Marine terraces, coral reefs now stranded on mountainsides, and submerged ancient forests all testify to these slow shifts. Standing at the edge of the sea today is standing at a boundary that has moved countless times, each position held for only a brief moment. In geological terms, the oceans breathe with the planet, rising gently and falling softly, shaping coastlines through cycles that have repeated long before humanity appeared and will continue long after. Continents converge and break apart in vast supercycles that unfold over hundreds of millions of years, drifting across the surface of the planet like slow, wandering rafts. This motion is driven by the mantle's deep, steady circulation, bringing land masses together into supercontinents and then pulling them apart again. When continents collide, they lift mountain ranges and create new habitats. When they separate, they open oceans and form new coastlines. These supercycles have repeated many times, forming ancient landmasses like Rodinia, Pangaea, and Gondwana. Eich cycle reshaped climate, ocean currents, and the evolution of life itself. Watching a supercontinent form would be like watching continents dance in slow motion, approaching one another over tens of millions of years, touching gently and drifting apart once again. The continents we know today are simply snapshots in a long, flowing story of movement. Their journeys remind us that Earth's surface is never still, but follows deep rhythms older than mountains or seas. Young mountain ranges rise and rejuvenate themselves through uplift, even as erosion slowly wears them down, creating a delicate balance between growth and decay. Deep within the crust, tectonic forces push rock upward, lifting peaks that scrape the sky. At the same time, wind, water, ice, and gravity gently sculpt the mountains, smoothing their edges and carrying their sediments away, grain by grain. Some ranges experience pulses of uplift that refresh their height, while others slowly settle into rounded forms as they age. Across millions of years, mountains are born, grow tall, weather away, and sometimes rise again in renewed cycles. Each stage has its own quiet beauty, from sharp young summits to ancient, gentle ridges. The mountains we see today are only moments within this grand life cycle. They remind us that even the most massive structures on Earth are temporary, shaped by slow, intertwined forces that guide their evolution through deep time. Life evolves in response to geological change, adapting to shifting climates, rising mountains, drifting continents, and advancing seas. When landmasses join, species migrate and mingle. When they separate, isolated populations diversify into entirely new forms. Volcanic eruptions create fertile landscapes where new ecosystems flourish, while ice ages push species toward warmer regions, creating waves of movement across the globe. Even subtle changes, such as variations in ocean chemistry or atmospheric oxygen, influence the direction of evolution. The fossil record shows life responding not in sudden leaps but in gentle, persistent adjustments over millions of years. Each geological shift offers new opportunities, new challenges, and new paths for life to explore. The story of evolution is not separate from the story of the Earth. It is intertwined with every continental drift, every mountain uplift, and every slow change in climate. Life moves with the planet's rhythm, reshaping itself as Earth reshapes its surface. The rock cycle stretches far beyond the lifespan of any civilization, unfolding across millions to billions of years in a rhythm that feels almost eternal. Rocks are born from molten magma, uplifted into mountains, weathered into grains, carried to the sea, buried under sediments, transformed by heat and pressure, and eventually melted again to restart the sequence. Human history occupies only the thinnest surface layer of this cycle, a moment so brief that even a pebble's journey from mountain to coastline vastly exceeds it. While civilizations rise and fall, rocks continue their slow transitions, each step shaped by gravity, heat, water, and time. The stones in ancient temples, the cliffs above modern cities, and the grains beneath our feet have followed pathways older than writing. Agriculture, or culture itself, the rock cycle reminds us that Earth's processes move at a pace we can barely comprehend, maintaining a gentle continuity that outlasts empires, eras, and epochs. Earth's magnetic rhythm reverses polarity in cycles that span hundreds of thousands to millions of years. A slow turning of the planet's internal compass. Deep within the core, molten iron flows in patterns that generate the magnetic field, and over time, these patterns shift until the north and south magnetic poles gradually weaken and swap places. The transition is not sudden but spreads through centuries, leaving subtle magnetic signatures in cooling lava and sediments. These records allow scientists to trace the timing of reversals, revealing a long sequence of field flips woven throughout Earth's history. Even during reversals, life continues without disruption, guided by the planet's enduring stability. Magnetic changes remind us that Earth carries its own heartbeat beneath the crust, a slow pulse of flowing metal that shapes navigation, auroras, and the protection of our atmosphere. This gentle, long-period rhythm is another voice in Earth's deep conversation with time. Large volcanic eruptions shape long-term climate in ways that unfold gradually, influencing temperature, rainfall, and atmospheric chemistry over decades or centuries. When volcanoes release vast amounts of ash and sulfur into the atmosphere, these particles reflect sunlight and cause temporary cooling at the surface or along aspects. Repeated eruptions can shift regional climates, alter ocean currents, and affect ecosystems in subtle but lasting ways. These climatic influences are recorded in tree rings, ice cores, and sediment layers, revealing patterns of cooling and recovery that echo through Earth's history. Even the largest eruptions are part of a broader geological rhythm, interacting with tectonics, ocean circulation, and biosphere feedbacks. The effects emerge slowly, like ripples across a vast pond, shaping the environment at a pace much gentler than the eruption itself. Volcanoes remind us that even dramatic events contribute to long, patient cycles that guide Earth's climate through ages of change. Coral reefs grow in warm, shallow seas, building intricate calcium carbonate skeletons that eventually harden into limestone mountains over millions of years. As corals live and die, their structures accumulate layer upon layer, forming reefs that rise toward the sunlight. When sea levels fall or tectonic forces lift the ocean floor, these reefs emerge as towering cliffs, karst landscapes, and vast limestone plateaus. Within these rocks remain fossil corals, shells, and traces of ancient marine life, all preserved in delicate detail. Limestone mountains in many parts of the world began as living reefs teeming with colour and movement. Long before land animals existed, the transition from reef to rock is slow and gentle, shaped by growth, burial, uplift, and erosion. Coral reefs turning to stone is one of Earth's quiet miracles, showing how the living world becomes part of the geological world, carrying the memory of ancient seas into the heart of continental landscapes. Continental shelves drift slowly along with the mantle beneath them, moving at rates so small that only precise measurements can detect the motion. These broad underwater platforms form the edges of continents, extending outward beneath shallow seas and hosting diverse ecosystems. As the mantle circulates in deep, steady currents, it carries the continental plates on its surface, guiding their gradual migration across the planet. The shelves shift with them, rising or sinking as crust thickens, thins, or flexes. Over millions of years, entire coastlines move, shelves widen or narrow, and seas deepen or retreat. These movements are not violent, but gentle adjustments in Earth's outer shell, driven by the slow breathing of the mantle. The drifting shelves remind us that even the most stable places we know, the edges of continents, are part of ongoing journeys shaped by forces far below. They are quiet travelers on a planet forever in motion. Soil forms from weathered rock in complete silence, created through the slow work of wind, rain, roots, and time. At first, rock breaks into small fragments, then into finer grains as water seeps into cracks and expands with each freeze and thaw. Plants contribute by sending roots into fractures, loosening minerals and drawing nutrients upward over centuries. Organic material from fallen leaves and ancient microorganisms blends with these mineral grains, creating the dark, fertile earth that supports forests, fields, and entire ecosystems. The transformation happens so gradually that no single moment announces the birth of soil, yet it becomes the foundation for nearly all life on land. Soil is Earth's quiet cradle, a mixture of stone and life woven together so slowly that its creation feels like a whisper. Its richness comes from patience, from countless seasons of gentle breakdown and renewal. Every handful of soil carries the memory of mountains, rain, and centuries of quiet formation. Minerals within soil nourish plants through many seasons, dissolving just slowly enough for roots to absorb them while still remaining part of the earth. Elements like potassium, calcium, magnesium, and phosphorus move through the soil in tiny amounts, guided by water, microbes, and root hairs so fine they resemble threads of breath. As plants grow, they draw these minerals upward, weaving them into stems, leaves, and seeds that eventually nourish animals and people. When plants die, their nutrients return to the soil, beginning the cycle again. This exchange is gentle and generous, a quiet partnership between rock and life that has supported ecosystems for hundreds of millions of years. The minerals do not hurry, and the plants do not take more than they need. Soil becomes a slow-flowing reservoir of nourishment, renewing itself through rhythm rather than force. It is Earth's way of feeding life with patience, offering steady support through every changing season. Groundwater moves through layers of rock like a slow breath, sinking through grains of sand, slipping between minerals, and collecting in hidden aquifers deep below the surface. This water begins as rainfall or melting snow, which trickles into the earth and follows tiny pathways carved by time. As it moves, the water picks up minerals in delicate amounts, becoming enriched with the chemical signature of the rocks it passes through. Some groundwater travels only a short distance before emerging again as springs, while other water may remain underground for centuries before resurfacing. The movement is unhurried and silent, shaping caves, nourishing deep-rooted plants, and supplying wells and rivers. Groundwater reminds us that not all water rushes. Some drift slowly through stone in long, meditative journeys. It is Earth's hidden circulation system, carrying coolness, minerals, and quiet renewal through its underground veins. Every drop that rises again carries the calm memory of its time in the deep. Hot springs bring minerals to the surface like gentle messages from Earth's interior, rising through cracks warmed by geothermal heat. As water travels downward through layers of rock, it absorbs dissolved minerals that were locked away for millions of years. When this warmed water rises again, it emerges as a spring that shimmers with dissolved silica, sulfur, calcium, and other elements. The heat feels ancient, as though carried upward from a deep, glowing hearth beneath the crust. These springs often create soft terraces, colored pools, and delicate mineral deposits that build slowly over time. For thousands of years, people and animals have sought these warm waters for comfort, healing, and connection to the land. A hot spring is Earth whispering gently through water, reminding us that the planet is alive and generous. Each rising bubble carries a hint of the deep interior, offering warmth in a world shaped by stone and time. Trace minerals help keep living bodies healthy, supporting everything from bones and blood to nerves and enzymes. These minerals originate in rocks that weather into soil, dissolve into water, and travel through plants before finally entering animals and people. Even in tiny amounts, elements like zinc, copper, iodine, and magnesium play essential roles in maintaining life. Their journey begins in the deep earth, where they formed under immense heat and pressure long before life existed. Over millions of years, they moved slowly outward through wind, rain, rivers, and soil, eventually becoming part of the biological world. Every cell in a living body contains minerals that once sat inside mountains, crystals, and ancient seas. This connection links life directly to the geological world, showing that our strength, balance, and energy all depend on the Earth's patient mineral cycles. Trace minerals are quiet gifts from stone to life, offered across ages with gentle consistency. Forests rise where broken rock slowly gathers, forming a foundation that begins as bare debris but eventually transforms into living soil. After landslides, glacial retreats, or volcanic eruptions leave behind rubble, wind-blown dust and drifting seeds begin the long work of renewal. Mosses and lichens settle first, their delicate growth loosening minerals grain by grain. Small plants follow, sending roots into cracks and adding organic matter as they live and die. Over centuries, the mixture of weathered stone and decayed vegetation becomes rich enough to support shrubs, then trees, and finally, entire forests. Standing in such a forest feels like witnessing life growing directly out of stone. Each trunk and leaf rooted in patient geological transformation. These forests are reminders that new beginnings often come from the quietest places, nurtured by time more than anything else. What begins as cold, lifeless rubble becomes a sanctuary of shade, fresh air, and thriving ecosystems through Earth's soft and persistent care. Volcanoes create fertile soils that nourish crops for generations, transforming molten rock into dark earth, rich with minerals. When lava cools, it fractures into fine particles that weather quickly under rain, wind, and plant roots. These particles contain nutrients like iron, magnesium, potassium, and calcium, which dissolve slowly into the soil and become available to plants. In many regions of the world, communities farm on volcanic landscapes because crops grow vigorously in this nutrient-rich earth. Fields of rice, coffee, grapes, and vegetables flourish on land that was once glowing magma. This transformation from fire to food represents one of Earth's most gentle miracles, violent eruptions giving way to thriving life. Volcanic soil is a testament to the planet's ability to renew itself, turning destruction into abundance. It shows that even the most dramatic geological events ultimately contribute to long-term fertility, feeding forests, wildlife, and human societies with minerals that were once locked deep inside the earth. Melting ice opens pathways to new valleys, shaping landscapes with patience rather than force. As glaciers retreat, they leave behind broad basins, smooth rock surface, and long U-shaped valleys carved through centuries of slow movement. When the ice finally melts, streams begin to flow through these valleys, carrying sediments that nurture new vegetation. Pioneer plants colonize the bare ground, creating pockets of soil that gradually expand into meadows and forests. Lakes form in depressions left by blocks of melting ice, becoming habitats for birds, fish, and delicate aquatic plants. Every element of this landscape bears the signature of glacial touch: polished stones, winding rivers, and gentle slopes that trace the former path of ice. Glacial retreat may seem like an ending, but it is also a beginning, revealing land that has waited quietly beneath the ice for thousands of years. These new valleys remind us that Earth renews itself even in cold silence, making space for life to flourish again. Rock stores warmth during the day and releases it slowly at night, creating gentle cycles of temperature that influence entire ecosystems. Sunlight heats stone surfaces, filling them with warmth that sinks deeper into the rock as the day progresses. When night falls, this stored heat radiates outward, keeping nearby air, soil, and plants slightly warmer than the surrounding environment. This subtle warmth can extend growing seasons, protect delicate organisms from frost, and create microhabitats where specific species thrive. In deserts, rocks become refuges for animals seeking cool shade during the day and gentle warmth at night. In mountainous areas, mosses and lichens grow on stones because the heat release supports their nighttime survival. This daily exchange of energy is a quiet partnership between sun and stone, a back-and-forth rhythm that supports both plants and animals without any noise or hurry. Rocks act as small, steady hearths scattered across the landscape, warming life through their patient thermal memory. Ecosystems rely on geological cycles to renew themselves, drawing stability and nourishment from the long rhythms of rock, water, and soil. Weathering breaks down stone into nutrients that feed plants, which in turn support animals and replenish soil when they decay. Rivers carry sediments that rebuild floodplains, while volcanic eruptions add minerals to landscapes that will one day host forests and farms. Tectonic uplift raises new mountains whose erosion creates fertile valleys, renewing the land in slow, ongoing cycles. Even the smallest organisms participate, breaking minerals apart, forming soil, and guiding chemical exchanges essential to life. Over millions of years, ecosystems rise, flourish, decline, and re-emerge in harmony with geological processes. This interplay between living creatures and the solid earth beneath them is soft, continuous, and profoundly interconnected. It reminds us that life is not separate from geology. It is part of the same patient cycle of transformation, nourished by the planet's slow, steady rhythms. Every fossil is a letter from a distant past, written in the language of bone, shell, and stone. When a creature dies, most traces of its life disappear, but under just the right conditions, its body becomes buried in sediment where time moves slowly and gently over thousands or millions of years. Minerals replace the original material grain by grain until the fossil becomes a preserved echo of the once living form. These imprints capture delicate details like the curve of a shell, the veins of a leaf, or the pattern of ancient footsteps. Holding a fossil feels like holding a story that traveled across ages to reach your hands. It is a message from a world that has vanished, yet remains alive in stone. Fossils remind us that the earth remembers even the smallest lives, preserving their shapes and gestures so that long after they are gone, their presence can still be felt in quiet moments of discovery. Layers of rock reveal ancient climates through the colors they carry, each shade reflecting a different moment in Earth's atmospheric history. Red beds often form in warm, oxygen-rich environments, while deep black shales suggest low-oxygen seas where organic material settled undisturbed. Pale limestone hints at tropical waters, and rusty hues point to iron-rich landscapes that once baked under arid skies. These colors were not painted by human hands, but emerged naturally as minerals reacted to temperature, water, and air long before life walked the land. When you look at a cliff, face striped with reds, greys, yellows, and whites, you are seeing a timeline of climates layered like quiet chapters in a book. Each band of color is a memory, a coded record of sunlight, rainfall, wind, and ancient environments that existed for millions of years. Rocks hold these memories with astonishing patience, keeping the palette of Earth's past preserved in stillness. A grain of sand tells the story of its journey from mountain to sea, shaped by countless small encounters with wind, water, and time. It may begin as part of a towering cliff or rugged peak, broken off by frost or rain, then carried into a river where it tumbles downstream. Along the way, the grain becomes smoother as it rubs against other stones, dissolves slightly in water, and settles temporarily in quiet pools before being lifted again by the current. Eventually, it reaches a delta or shoreline, where waves continue to sculpt it into a more rounded form. Every grain has lived through an incredible voyage across valleys, riverbeds, and shorelines, experiencing both movement and rest in cycles that span thousands of years. When you hold sand in your hand, you are holding fragments of old mountains that have traveled quietly across the landscape. Each grain carries the memory of geological time written in its shape. Sedimentary rocks record old lakes, seas, and rivers through their layers, preserving traces of the environments that once covered the land. Fine-grained mudstones capture the stillness of ancient lake beds, while coarse sandstones remember the rush of long-gone rivers. Shell fragments, ripple marks, mud cracks, and even raindrop impressions remain hidden within these rocks, offering glimpses of everyday moments from prehistoric Earth. Over time, sediments accumulate gently, layer upon layer, each one holding a record of a place where water once flowed or pooled. When these layers harden into stone, they preserve a history that stretches far beyond human memory. Walking along sedimentary cliffs is like reading an old diary where every line is written in minerals rather than ink. These rocks remind us that landscapes are constantly changing, and the world we know today sits atop countless buried stories of waters that came and went in deep time. Solidified lava flows mark the precise moment of an eruption, capturing the instant when molten rock emerged from the earth and cooled into stone. When lava spills across the surface, it glows with intense heat before gradually darkening as it loses energy to the air and ground. Within hours or days, the molten river becomes a hardened sheet of basalt or andesite, preserving the shapes of waves, bubbles, and textures that once moved with fiery motion. Some flows cool with ropey patterns, while others form tall columns as they contract. These frozen features act like geological timestamps, locking a moment of volcanic activity into the crust, long after the eruption's sound has faded and the ash has settled. The lava flow remains as a quiet monument to the event. It is Earth's way of marking time through stone, recording the moment when deep heat briefly touched the surface before returning to silence. Glacial striations appear as quiet scratches carved into ancient rock, created when massive ice sheets moved slowly across the landscape. As glaciers advanced, they carried stones frozen into their bases, dragging them along the bedrock beneath with steady pressure. These stones carved long, parallel grooves that recorded both the direction and the rhythm of the ice's slow journey. Though the glaciers have long since melted, the marks remain, preserved like soft signatures left by the planet's frozen hand. Walking across rock polished by ice feels like stepping into a memory carved during a colder world, where silence dominated valleys and mountains. Striations remind us that even immense forces can leave behind delicate traces, telling us where the ice once traveled. Paused or turned, they are quiet fossils of motion, etched not by life, but by the slow breathing of the Earth's climate. In each groove lies a whisper of ages, when ice shaped entire continents grain by grain. Rare minerals record ancient meteor impacts, capturing the high-energy moments when celestial bodies collided with the Earth. During such events, intense heat and pressure transform common minerals into unusual forms, creating shock vines, high-pressure crystals, and glass-like melt structures that could not form under normal geological conditions. These minerals hold within them the memory of the instant when rock briefly behaved like fluid, reshaped by forces more powerful than any eruption or earthquake. Over time, erosion may soften the crater's edges, forests may grow over the land, and lakes may fill the depression. But the minerals remain as quiet witnesses. Studying them allows scientists to reconstruct cosmic events that occurred millions of years before humans appeared. These rare crystals act like tiny archives of starlight and stone colliding, a moment when Earth and the heavens touched. They remind us that our planet's history includes not only slow geological rhythms, but also brief, brilliant flashes from beyond the sky. Stratigraphic layers serve as the diary of millions of years, each band of rock marking a different chapter in Earth's long story. These layers form as sediments accumulate year after year, compacting under their own weight until they harden into stone. Some layers are thick and robust, representing long stretches of stability, while others are thin or disrupted, capturing sudden changes like floods, volcanic eruptions, or shifts in climate. Fossils, mineral grains, chemical signatures, and color variations all contribute to this vast geological journal. When scientists read these layers, they uncover stories of ancient oceans rising and retreating, forests expanding and shrinking, and continents drifting across the globe. Stratigraphy reveals not just events, but rhythms, showing how environments evolved over time. Each layer offers a soft whisper from the past, a reminder that the ground beneath our feet has been recording its own experiences since long before humanity learned to write. Every layer of rock is a single breath of the earth, a pause in time when sediment settled into place before being covered by the next. These layers accumulate through quiet processes like river deposits, volcanic ash, falls, or the settling of microscopic organisms in ancient seas. Over millions of years, these moments stack upon each other, creating immense sequences of stone that record countless cycles of environmental change. The thickness, texture, and composition of each layer reflect the conditions at the moment of its formation, revealing stories about climate, life, and landscape. To study these layers is to listen to the earth inhale and exhale slowly across epochs. These breaths become stone, carrying the cadence of deep time. When we look at a cliff face or a canyon wall, we are witnessing thousands of such breaths, each one preserved in perfect stillness. Rock layers remind us that the planet moves not only in grand shifts, but also in quiet pulses of sediment and time. Pollen fossils tell the stories of vanished forests, preserved in tiny grains that drifted into lakes, bogs, or quiet ponds millions of years ago. Each grain of pollen carries the distinct shape of the plant that produced it, allowing scientists to reconstruct ancient ecosystems with surprising detail. Buried in sediment and protected from decay, pollen becomes a microscopic archive of landscapes long gone. By studying these grains layer by layer, researchers can trace how forests grew, retreated, or changed as climates warmed or cooled. Even when the trees themselves have disappeared and their wood has long since weathered away, the pollen remains as a soft echo of their presence. These tiny fossils speak of seasons, winds, and cycles of flowering that once filled ancient valleys and plains. Pollen is Earth's quiet memory of life's delicate patterns, a record of forests that breathed, shaded, and sheltered the world before disappearing into deep time. Continents drift as slowly as clouds made of stone, moving across the planet's surface at a pace far too gentle for human senses to notice. They glide on the soft, steady currents of the mantle, shifting only a few centimeters each year. Yet, over millions of years, their motion rearranges oceans, climates, and ecosystems. This continental drift has been happening since Earth's earliest ages, guiding the formation of supercontinents and their eventual breakup. To imagine continents in motion is to imagine a world breathing over geologic time, with land masses drifting apart like calm rafts on a vast ocean of stone. Mountains rise where continents meet, and deep seas form where they separate, all through slow, patient movement. Even now, as we sleep, the continents continue their quiet journey beneath the continents and oceans we know. Their motion is a reminder that Earth itself moves with a rhythm too deep to feel, a slow dance that has shaped life since its beginning. Mountains rise and then wear down again, according to rhythms that span millions of years, growing upward through tectonic uplift and slowly softening under the touch of wind, rain, and time. Their growth is fueled by deep internal forces, pushing layers of rock toward the sky, inch by inch, over enormous spans of time. Meanwhile, erosion gently rounds their edges, carries their sediments to distant valleys, and sculpts them into calm, rolling forms. New mountains are sharp, jagged, and bold, while older ranges become smooth and quiet, their peaks softened by centuries of weather This cycle of uplift and erosion is like a long, slow heartbeat of the earth, a rise and fall that continues without rush. Mountains remind us that strength can be both fierce and gentle, and that even the tallest peaks eventually return to the plains. Their life cycle is a meditation in stone, showing how change unfolds through patience. Rivers erode rock in a silent waltz, shaping valleys and carving canyons through movements so soft and continuous that the landscape seems unchanged from one moment to the next. A river does not hurry. It flows around obstacles, glides over stones, and carries tiny grains of sediment that slowly wear away the rock beneath. Over thousands of years, these gentle motions carve deep pathways through mountains, creating smooth curves, quiet rapids, and reflective pools. A river's current is like a dancer following a calm rhythm, tracing the same path day after day, year after year. Even the mightiest canyons began as small streams whispering across stone. Each bend and curve in a river's course is a record of its steady persistence, shaping the land through soft, repeated touch rather than force. Rivers teach us that even the quietest motion can change the world. Given enough time, wind shapes sand into natural curves, guiding each grain with motions that feel almost like a sculptor's breath. As breezes sweep across open landscapes, they lift tiny particles and let them fall in gentle arcs, forming ripples, dullness, and waves that shift subtly with every sunrise and sunset. The curves created by wind are never harsh. They follow the natural flow of air, creating soft ridges that look like they were drawn with a delicate hand. Over years and centuries, these wind-shaped forms migrate across deserts, coasts, and plains, carrying the memory of every breeze that touched them. The patterns they leave behind resemble the lines of a fingerprint or the ripples on a calm pond. Wind-carved sand reminds us that even invisible forces can create beauty, shaping the land through movements so light they feel like whispers. Watching dunes change is like watching Earth breathe through the air itself. New soil forms from ancient rock fragments, beginning as coarse debris before transforming into the soft earth that nourishes life. Rain, frost, plant roots, and time work together to break rock into tiny pieces, gradually mixing it with organic matter from fallen leaves and microorganisms. Over centuries, this blend becomes fertile soil, capable of supporting forests, grasslands, and entire ecosystems. Each handful of soil contains minerals that once lay deep within mountains and organic matter that once belonged to living plants and animals. The creation of soil is a slow, nurturing process, turning stone into a cradle for life. It reminds us that even the hardest materials can soften, becoming part of a cycle that renews itself endlessly. Soil is Earth's gentle gift, formed through quiet transformation and carrying within it the memory of rock, water, and time, all blended into something new and living. Deep canyons exist because countless seasons of rainfall have flowed through the same pathways, drop by drop and year by year, allowing water to carve gently downward through layers of stone. Each rainy season adds only the slightest touch, carrying fine grains of sediment away and smoothing the canyon walls one breath-like movement at a time. Over tens of thousands of years, these tiny changes accumulate into vast, peaceful chasms that stretch toward the horizon. A canyon is not the result of forceful destruction, but of patient shaping. The slow artistry of water following gravity's soft invitation. As you stand at the edge of such a canyon, What you see is the memory of storms long gone and rivers that kept returning, season after season, simply doing what they always do. Their persistence becomes beauty, and their quiet rhythm becomes depth carved into the earth itself. Ancient rocks deep within the earth hold heat, in the same way a warm clay pot holds the memory of fire long after the flame has faded, buried under layers of stone. These rocks store geothermal warmth that has traveled upward from the planet's core for billions of years. This heat rises slowly, seeping through fractures, feeding hot springs, and providing a gentle reminder that Earth is alive from within. When you touch a stone warmed by sunlight, you feel a small echo of this deeper warmth, a resonance between surface and interior. Beneath mountains, plains, and oceans lies a reservoir of energy that moves with the calm consistency of a heartbeat, radiating heat outward in a steady, unhurried flow. This inner warmth has shaped landscapes, fueled volcanic cycles, and created environments where early life first flourished. In its quiet persistence, the Earth's heat becomes a message of continuity. The silence between major geological events stretches so far that it becomes almost unimaginable on a human timescale. While earthquakes, eruptions, and mountain-building episodes may seem dramatic, the intervals between them are often defined by deep stillness. During these spans, sediment settles layer by layer. Rivers continue carving their paths, and continents drift at a pace too slow to feel. This geologic quiet is not emptiness, but a period of subtle preparation, where small changes accumulate like soft breaths in the background. Over millions of years, these silent intervals allow ecosystems to grow, climates to stabilize, and landscapes to mature. They remind us that Earth's story is not written in sudden motions, but in the long pauses between them. In those stretches of quiet time, the planet simply continues being itself, unchanged by urgency and untouched by haste, offering a rhythm that gently encourages us to slow down as well. Earth always returns to balance, no matter how dramatic its changes may seem in the moment. After eruptions, landscapes cool and regrow. After earthquakes, stress redistributes and the crust settles into a new equilibrium. During ice ages, glaciers advance and then retreat, allowing life to adjust gradually over thousands of years. This resilience is woven into the planet's design, a constant cycling between build-up and release, uplift and erosion, warmth and cold. Even when forces within the mantle shift, or when oceans rise and fall, Earth responds with slow adjustments rather than chaos. This tendency toward balance is what has allowed life to persist through countless transitions, adapting to new conditions as the planet finds its way back to stability each time. To witness this balance is to understand that change is followed by calm, and upheaval is softened by time. Every stone you touch carries a fragment of the ancient universe, a piece of matter that once drifted through interstellar space before becoming part of Earth. These rocks formed from stardust, cooled in early oceans, crystallized under mountain pressure, or erupted from glowing lava millions of years ago. Within each pebble and boulder is a quiet memory of cosmic origins, to a reminder that the solid ground beneath your feet was once part of something far larger and older than the planet itself. When you hold a stone, you are touching time stretched across billions of years, shaped by gravity, water, heat, and calm repetition. It is a piece of Earth's deep story, but also a piece of the universe's beginning, carried gently through epochs to reach your hand. Stones are not just objects, they are silent messengers from the cosmos, resting in the present after a journey that began among the stars. And now, with these 100 gentle truths, your breathing begins to soften as the ancient rhythms of Earth settle quietly around you. Thank you for drifting through these quiet truths of our planet tonight. Beneath every mountain ridge, beneath every grain of sand, and beneath every stone along your path, the Earth holds a memory older than anything we can imagine. And yet, it continues to move slowly. Breathe gently and care for life with a steadiness that never wavers. As you settle into rest, imagine those slow tides of stone and time supporting you, the deep warmth of the mantle, the patient rise of mountains, the whisper of ancient oceans. All of it continues in peaceful silence, untouched by hurry, untouched by noise. Let your thoughts soften the way sediment settles at the bottom of a quiet lake. Let your breath fall into the same slow rhythm that shapes canyons and lifts continents. Tonight, the Earth holds you the way it has held life for billions of years, calmly, steadily, without expectation. If you're still awake, take a moment to tell me where you're listening from. Your words help other dreamers find this space of calm. And now, let the weight of the day slide away. Let your mind drift like a stone sinking through ancient water. The world is quiet. You are safe, and sleep is already reaching for you. And now, you can rest